Just some logistics that don't need to be on the recording. We'll cut it out later. There's a bathroom in the back. There's a water fountain with some cups and there's cookies. So make yourselves comfortable. Sandra is a very lovely person who I've had the pleasure of getting to know this past hour, and I'm very excited to hear her speak. She graduated from Humboldt and recently found the passion for dragonflies about 15 years ago. She's going to tell us all about them today, the jewels of the Marsh. And please, let's give Sandra a warm welcome.
Thanks, everyone. Yeah, like she said, about 15 years ago, I started my passion with dragonflies. I'm passionate about wildlife and found out that there's different levels of passion. So what do you know? I start my presentations with thank yous because they always left at the end and don't get the attention they deserve. So first of all, I'd like to thank Friends of Arcata Marsh for inviting me and reminding everyone of all the good work they do and to get on their website and see how you can participate. I'd also like to thank my co-author, Kathy Biggs. She's been my mentor for all 15 years. She took me under her wing, and I could not have catapulted my knowledge the way that I did without her attention. And then this is Ken Merswa. This is my one warning I give everyone. You're likely to get ode fever once you start looking at dragonflies. This was my spark dragonfly. Those green emerald eyes are just to die for. Ken brought me to Illinois to work on the Heinz emerald dragonfly, and I've been a dragonfly nut since. So we're going to start out with a little bit of why we should be looking for dragonflies, a little bit of language that's important. We're going to try to go quickly through anatomy, life cycle, the difference between dragonflies and damselflies, a little bit on migration, one slide on BTI, and then we'll go to ID of some of the more common species at the marsh. So it's very selected species. Perfect. Yeah. Thank you. Uh-oh, but now we're back to this, where I can't move the slides. Oh, did it go?
Yes.
Oh, perfect. All right, so number one reason is it's fun, right? Gets you outside. And if you're a birder, and I assume a lot of you are, it extends your trip. So in the morning, you go out and go birding, and as the birds start to wane, the dragonflies start to come up with the sun and the heat. And then at the end of the birding season, that's when they get plentiful. July, August, September, that's when they're out, especially here. And so it can extend your season of going out and about. And if you are a birder, you already have all the skills you need. And I like to call it dragon hunting, and that just sounds really cool. But most people call it oding. So this is my one bird on the slide. So dragonflies and damselflies are in the order Odenata, which means toothed ones. And that creates a little bit of confusion because they're commonly known as dragonflies, but it also includes damselflies. And so when you talk to Odenate biologists, when they say dragonfly, they might mean the inclusion of both. So in the suborder Anisoptera is dragonflies, and the suborder Zygoptera is damselflies. So for the purposes of this meeting, when I say dragonfly, I mean Anisoptera. When I say damselfly, I mean Zygoptera. And if I mean to include both, I will call it an ode or an Odenate. And as was done with birds, the Dragonfly Society of America gave official common names to all of the dragonflies and damselflies in North America. So, quick anatomy. The dragonflies are insects, and so they have three main parts: the head, the thorax, and the abdomen. The abdomen is often called a tail, especially in names, but it is not a tail as in mammals. It is actually the abdomen. For Odenates, the head is mostly consists of the eyes. They're just massive. The thorax holds 4 wings, individually muscled, and the abdomen has 10 segments plus the sexual appendages. The 10 segments are important for ID because often we talk about a particular color or pattern on segment 8, for example. And segment 1 can be really hard to find, so it's often easier to start from 10 and move backwards. And that sounds simple, but when you're out there doing it at the beginning, you always tend to want to start at 1. Don't, start at 10. And then the same is true for the nymph. They also have the 10 segments, and the head, thorax, and abdomen. All right, so we'll start with the eyes, the head. And their eyes have 30,000 facets, which compared to a housefly, which is what we're used to, only has 4,000. And so they are highly, highly sensitive to movement. If you had dragonfly eyes, you would have 2 football helmets of eyes on the sides of your heads. You'd have a 360-degree view. And like I said, you'd be so sensitive to movement. On the thorax, again, we have the 4 wings. They are individually muscled and they move independently. And this is a good place to talk about the fact that dragonflies are insects, and so they are exothermic and therefore need sun to warm up. So that's why you don't tend to see them early in the mornings. They need a little bit of time for the sun to warm up. And here in Humboldt County with the fog, our mornings start a little later with dragonflies. And so they will come out before the sun comes out, but it's that when that fog is just light and you can start feeling the sun rays on your back, that's when the dragonflies start coming out. So more about the wings. They can fly a lot like hummingbirds, but they have 4 wings. So you can imagine the acrobatics that they can do. The military has put them in wind tunnels. They've been trying to copy the acrobatics that dragonflies can do to no avail, which I think is great. And then if you really get into serious dragonfly ID, there are times where venation can be very important for ID, but just a few species. The appendages, often we talk about those as naughty bits. The dragonflies and damselflies have either 3 or 4, and they're used for us for sexing and ID. They act as a lock and key, and so therefore they are species specific. A quick life cycle. So they lay eggs in the water or wet wood or stems of plants. The eggs will then hatch. They will turn into nymph. They will go through about 13 or 14 cycles. Then they will emerge out of the water. Once they emerge, they're teneral. They have no color whatsoever. This is when they cannot fly, and this is when the birds go nuts. Then once they go off and harden and color up, then they will go and copulate in this wheel. This is very Odenate specific. They're the only insects that do this. They're both facing forward rather than having end to end. And then once fertilization has occurred, the female goes and lays eggs, and sometimes she does it alone, but depending on species, she's often guarded by the male. Sometimes it's touch guarding where they stay attached, and other times it's hover guarding where they're just maintaining other males' distance from above the female. All right, I have to go through this emergence because this is just an incredible thing. When they come out of the water, they'll come up and down emergent vegetation till they pick the one they want. And then they'll split their backs and push the fore part of their body out, and they'll hang upside down like this until their legs harden enough that they can then bring themselves up and be able to pull the abdomen out. Then they'll start pumping up their hemolymph, sort of blood, just like butterflies do, and they'll pump up their wings and their bodies. You can see in the second picture there how much bigger it already is than the casing that it came out of. And then they will stay and dry for a little while. And at this point, they're considered teneral. And when they're teneral, their wings are still soft. They can still fly. And their colors are very muted. And a lot of their patterns aren't showing yet. So this is the most difficult time to ID. The exoskeleton that they leave behind is called an exuvia. The only thing you can get DNA from are these little tracheal linings. It's kind of like your hair. You can only get the DNA off the root where the cells from your head are left behind. And that's true with both dragonflies and damselflies. And when you do see these things, it confirms that that species can successfully complete its life cycle in that body of water. So to talk a little bit about the difference between dragonflies and damselflies, dragonflies are more robust and thick, and damselflies are like needles and tiny and really thin. And the dragonflies hold their wings out, and the damselflies hold their wings behind their abdomen. The wings are different. If you find a wing on the ground, which you often do as birds flick them off after they catch them, if you get a dragonfly wing, you will know right away if it's a forewing or a hind wing. But with a damselfly, you're going to have a little extra work to do. The eyes, like I said, are huge for both of them. But for dragonflies, they either meet and create a seam in the middle, or if they are separated, you could only fit one eye in the middle and all three would touch. The damselflies are more like hammerhead sharks. They have their eyes out on the edges, and you could fit 2 or 3 eyes before all of them would meet if you put them in between. They have a different clasping point during the mating process. In dragonflies, the male clasps behind the head, and in damselflies, it's on the protothorax or the front part of the thorax. And so this is where the lock and key that I mentioned earlier happens. It has to fit, and the female has to like it. And then the difference in nymphs is similar. The dragonfly is more robust and just stocky in general, and the damselflies are thin and more delicate looking. And the damselflies have the gills outside of their body, and it's usually 3, although sometimes they break off, so sometimes it's less. And then the dragonflies have their gills inside their abdomen. They use jet propulsion, and so this is pretty smart, because if they need to get away, they use the jet propulsion, and they're getting extra oxygen at the exact time that they need it the most. Just a quick thing about damselflies versus mayflies. They look very similar when you first look at them. I used to mix them up all the time and still do every once in a while. The mayflies have the gills on the sides of their bodies that the damselflies do not have, and their eye position is different. It's on top instead of the sides, and their joints just look a little funky to me compared to damselflies. And then when they become aerial, the mayflies can look a little bit like dragonflies when they're first emerging before they spread their wings, as you can see on the picture. All of our dragonflies are carnivorous. Yes, they do eat mosquitoes, both at the aquatic and terrestrial phase, but that is definitely not all they eat. They will eat flies, wasps, gnats, pretty much anything they can catch. But in the aquatics, the larger dragonflies can eat small fish and tadpoles. I recommend going on YouTube and looking that up, because it is absolutely awesome to see. Dragonflies also have predators. I have a star next to birds, because there are a lot of birds who depend on dragonflies for the survival of their young. They are a huge, fat-laden piece of insect that is just really good, especially for things like red-winged blackbirds and swallows. You take questions in the middle or no? Because we have people online, I think it'll be easier to wait till the end if you don't mind. So amazingly enough, they do migrate. Some do migrate. Common green darners are the most well-known as far as migrators. So dragonflies have been around for about 300 million years when Pangea was still one big mass of land. They were about 2 feet in, their wingspan was about 2 feet, so huge. And then about 100 million years later, when Pangea was breaking up and birds and dinosaurs started to come along, they were obviously something that those birds and dinosaurs ate. And so something that I've never read in a book, but I posit as a possibility, is that dragonflies taught birds to migrate. As Pangea was starting to break up and the dragonflies moved back and forth between the areas, the birds followed them for food, and the ones that did so learned to migrate. But theory, we'll see. Variegated meadowhawks also migrate. They take the offshore winds up in Washington and Oregon, and they get pushed to the beaches, and they don't want to go over the ocean in general, so they amass the way they do here. And you can count them, how many per minute are going down. And dragonfly enthusiasts will call each other up and go, they're at this beach, and the next person will go further south and go, they're at this beach. And I have gone to the beach a million times, and they never show up. And so what we're finding is right at the southern part of Oregon, they disappear. And we don't know if they're going over the ocean at that point or over land. I suspect it's a little bit of both. I've talked to a lot of fishermen who have massive flights of dragonflies way off at sea. And there's a lot of landings on the coastal islands off the shore of California. But we also see them inland. So I think there might be a little bit of both depending on winds. If you broaden the term migration to include lateral and northern weather events, we had a big event in 2015 where the red saddlebags followed a sort of a monsoony storm that we had. It was a freak thing in the middle of summer. And so they had previously only been known as far north as Sonoma County. And the map did fill in a little bit after this, once we got some more sightings, but they made it all the way up well into Oregon. And they did not survive the year. So they made it for that season. We saw copulation. We're like, wow, this is great. But you can imagine that this is one of the ways that they can take advantage of finding new areas that might work for them. And with climate change, this might be something that's really important for them to be able to move to new areas. We are at the infancy of migration research. And we have different types of migration, or what you might call migration. We might need a new word. Some of them are seasonal, so north to south, winter and summer. Some are storm chasers. And we also have feeding swarms that we're not quite sure. And they tend to follow the same migration routes as birds. So do they following the same migration routes as birds, or the birds following the same migration routes as dragonflies? That we don't know. There has been work using stable isotopes, and that works great east of the Rockies, but in the Pacific Northwest, where we have lots of rain, that kind of falls apart. So that doesn't really work well for us on the West Coast. In 2006, we had the first radio transmitters put on common green darners. They followed them with cars and planes for 10 days. And they tended to do these 3-day movements. So every third day they would move. And this really matches what we see. Where in the fall, in September, October, we'll see these huge swarms of common green darners, and they're foraging, and they're just in these big groups. And then all of a sudden one day they're all gone. And then it'll happen again somewhere else. So so that completely matches. They did travel as much as 93 miles in one day. For a little, several inch critter is pretty darn good. They move with the winds, and they do follow the coastlines on the East Coast. Here, what I find is in the fall, you'll find these massive migrations going down the gorges of the rivers. And you don't really notice it until you're like stopped at the construction and you see a few dragonflies. You're like, well, there's a bunch of dragonflies. And then you look up and you go, oh my God, there's hundreds of thousands of dragonflies. So when you're stopped at all those construction sites, look up. So more recent research that I've been able to be a part of is in last year, we put Modus tags on dragonflies. We learned a lot. The glue was a huge issue, and we had size and weight concerns. And we also need more towers as their migration is shorter and not as fast as birds. So we regrouped and did it again this year, just last month, and we switched to CCT Blue Morpho tags, which use Bluetooth. It does mean that the Modus towers need a $250 upgrade, but that's not too bad. And but we can also get them with our Bluetooth phones. And in the East, they have a butterfly project where people go out and just search with their phones and see if they can get a connection. So there's about, I can't remember if we tagged 8 or 10 this year. So we might get some hits, we'll see. The most amazing thing about this technology now is they actually have solar powered ones, which could mean they could work indefinitely or as long as the dragonfly survives. We figured out the glue issue. These tags are much smaller and lighter. And so we feel that this is possible at a larger scale. And I think that for the West Coast, this will be the only way that we figured out migration patterns, as some of the other methods can't be used here. A quick thing about BTI. I used to tell people to use this stuff all the time for their ponds at home and all of that. And they always said, oh, there's no problem with it, right? Why did we ever even believe that? There is new research, especially out in France, that shows that there are problems with the digestive system of nestling birds. And then once you start going down that rabbit hole, there are other research papers about effects of BTI. So I now no longer suggest that. And what I have found that in my home pond is that when I have a good balanced pond, and my pond is a 250-gallon stock pond, so it's not like your typical pond. But when all the insects, all the aquatic insects showed up, the water beetles, the water mites, you just get a nice ecosystem, it really takes care of the mosquitoes. I don't see mosquito larvae in that pond, ever. They're taken care of. And that's not to say that a few don't get out, but I'm not getting the mass mosquitoes. So the important thing is to create good habitat within your pond so that the other species can control the outbreaks, the mosquito outbreaks. All right. So I got Kathy Biggs, who wrote one of the first books for California, was about to retire. She was my mentor, or she did retire, actually. And it took me about 2 years to convince her to work on this book. And so I'm very proud of that and very happy that she did. So it just came out last month, and they're back in stock as of yesterday. So that's exciting as well. If you want the spiral bound edition, you have to get it from Kathy or I directly. And then if you don't mind having the non-spiral bound, you can get that on Amazon. And then also coming up is Ed Lamb's book for the Dragonflies of North America. We have literally been waiting for this book for years. And so we're really excited, and we got the release date of October 15th, and you can pre-order it. So, and then I have to mention these other guides. The Dragonflies and Damselflies of California by Tim Manolis was written in 2003. And at the time, it was revolutionary, absolutely. And it still has great information. The maps, however, are completely outdated. At that time, we did not have complete range maps, and we still have a few gaps here and there. Some of the names have changed. But other than that, the information is still good. So if you see that book, it's still a good reference to have. Then the Dragonflies and Damselflies of Oregon has only 6 species for the missing for the far northern California. It includes both dragonflies and damselflies. It has really good comparative drawings. And I like to use more than one guidebook because everybody describes it slightly differently, and whatever hits with you might be different. And then the Dennis Paulson book, I'm going to say is don't start with that book. It is definitely the definitive book, but you're going to have to learn all the scientific lingo. You're going to have to get in the weeds. It has every single species in the Western United States and North, actually I should say North America, and is wonderful. But if you start with this, you're going to be overwhelmed and it's going to start as gibberish. Other web resources is Odenates Central. It's where we kept records for dragonflies for a long, long time, way before iNaturalist was around. It is how we maintain our voucher species for county records. So it has very important historical data on it. It is now linked to iNaturalist, but the iNaturalist, the person who puts it on iNaturalist has to have, the copyright has to be set pretty loosely for us to be able to upload it. But it is there. And then iNaturalist is really good. However, you have to be really careful about vouchering or who is vouchering the specimen. The AI is okay, often wrong. And there's this sense of wanting to trust AI, but also there's the point system for how many things you ID and how many things you agree with. And so there's a tendency of people just agreeing with whatever it says. So be aware of that. Kathy Biggs and Jim Johnson are super active on there. And if something's way wrong and it has the 3 vouchers to make it a scientific specimen, they'll email everybody and go, okay, we got to go and override that. So the dragonflies are decent and damselflies, but just need to be careful with iNaturalist because of that. Other web resources, Kathy Biggs's Dragonfly and Damselfly site, she keeps that updated and all the range maps are updated almost monthly. She's a little slower now because, you know, retirement, but she's still doing it. And at some point, she's probably going to give me the password and say, you're it. The Northwest Dragonflyer is a blog post by Jim Johnson. It's excellent. It has little quizzes for things that are difficult to learn. It's one of those sort of outdated. So some computers will let you go to the site and some won't at this point. And as far as I know, he's not going to update it any longer. And then if you are on Facebook, I started Western Odenata about 15 years ago. And it's a great place to learn. There's tons of people there willing to help you with ID or any other questions you have about dragonflies. All right, the tools that you should have. Of course, if you're a birder, you're going to be already way ahead. The birder hotspots that you guys have all figured out that are associated with water are great for dragonflies. And also just backyard ponds, they do show up there. Binoculars, of course, are good. It's best to have close focus binoculars. So a lot of the ones made for butterflies are also very good for dragonflies. And if you do end up handling dragonflies, you can use the binoculars backwards like a hand lens, like a little microscope. For the cameras, the autofocus digital cameras have a hard time focusing on the dragonfly or damselfly compared to the background. You can play with that, but it's really better to have a manual focus camera. And the ones that perch on stems will often like the stem they're on. So if you just go slowly, take a picture, it'll fly off, it'll come back to that spot, take one more step, take a picture, and just keep doing that. You'll have 50 pictures, but it'll get closer and closer and closer. And then for the ones that are patrolling along the shore, you can pre-focus where they're patrolling. And as they cross that plane, you can take a bunch of pictures. And that's how all those really excellent pictures of flying dragonflies get done by those professionals. Then if you do want to get serious and get a net and get them in hand, it is nice to be able to see them up close and personal. But you really need to know where you're allowed to do that. Insects get little to no protection. So there's a pretty wide range of where you can net them, but definitely not in any kind of parks or reserves or public lands, just no. And then if you are going to get into trying to ID a Exuvia or nymph, a microscope is absolutely a must. And oh, that picture got sideways. Oh well, got flipped. So to go over a little bit on identification. So it's form over pattern. Oh, where did all the lettering go? Form over pattern over color is what it's supposed to say. You will do the opposite naturally. When you first see a dragonfly, the first thing you see is the color. Then you'll see the patterns. Then if you get a good enough look, you'll see the form. Just remember when you're trying to differentiate, which order is the most important. So if you're trying to decide based on color, you should know that there's other things that trump color, because color can change with lighting, with lots of things. So form doesn't change. These are your appendages. Remember, those are the lock and key pieces on the males that are distinct for each species. Venation on the wings, the eye shape and size. Does it have a seam? What color is it? Is it a bicolored? Is it one single color? All those things don't change. The pattern, once they get past that initial stage and become hard and all colored up, as we say, the colors can change, but the pattern itself doesn't change. So you can look at the black, basically, black versus color, not black versus which color, but any color. And then color can change. So it changes with age, it changes with sex, it can change with temperature, especially the blues and purples. There's some damselfly females that will become pale when they're in copula. There's pruinosity, which comes with age. This picture that you see here, you can see like that white sort of wash over the abdomen. When that dragonfly was young, you didn't have any of that whitewash. That yellow spotting there was, or dashes, was super prominent. And then it will get to the point where that turns completely white and you will not see the yellow at all. And that is a type of wax, a waxy cuticle, very similar to the wax you see on plums. You know, you go to the store, they get that white, you buff it off. That's what happens. It's basically the same family of waxes. As far as sex is concerned, with reddish type of dragonflies, the females tend to be yellow, and subadult males look like females, just like birds. And then the blues, the females often end up green, but many of those have both gynomorph and andromorph phases, so female-like color and male-like color. So when you're trying to identify these species, you want to look, one of the first things that you can really see is the wings. Are they clear? Are they colored? Where is the color? What kind of color? So all those things are important. The body, what color is it? What shape is it? What is the pattern? And all of that. So this is very similar to birds. Does the bird have wing bars? Does it have spots on the body? Does it have, what shape is the bill? What color is the face? All of those things are important. I have a thing for dragonfly faces, so you're going to see a lot of them today. So both in dragonflies and damselflies, we're going to look at eye color and face color. You're going to look at whether the seam is black or if it's just a seam. You're going to see the eye color, the mandible color compared to the face color. All of those things can be important with ID. So from head to tail, you're going to look at the face color again and the eye color. The thorax, does it have stripes? So like birds, is it spotted? Is it striped? Is it white? Is it yellow? Is it on the back or just on the sides? On the abdomen, is it one color? Does it have pattern? Does it have spots? Does it have streaks? What colors are on what segments? And then the appendages, again, are important. So we're going to start with red dragons because that's what people see the most. And the red dragons are mostly meadowhawks, except for the skimmers. The flame skimmer is also in the red zone. And for them, you really need to pay attention to the markings on the abdomens, the wing and vein colors, the thorax spots or stripes, the eye and face color, the leg color, and wing position at rest. Does this sound a lot like birds? Absolutely. So the cardinal meadowhawk is the most common dragonfly species that you see in the red family. They are almost all completely red with white spots on the thorax. They sometimes have a little bit of red in their wings, and they definitely have those little black spots right at the base. If you see those little black spots, they're the only meadowhawks that have that. And then as you can see here, the female, so this is male, 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 female, yellow. As they get older, a lot of the female meadowhawks do tend to turn into orange and reddish colors, but then by that time they're ancient, so there's not too many of them. The flame skimmer, also red-ish. They're actually orange, but with lighting differences, they often look red. Or if you don't have something red next to it, you don't realize how orange it actually is. They also don't have any markings on the abdomen, but they're basically the same color all over, and they have a huge wash of red over their wings. The striped meadowhawk is red-ish. It's kind of a faint red, lots of browns. They have very faint stripes, both on the sides and the top of their thorax. A couple of species have that as well when they're young, but not as they mature. They have completely clear wings, except every once in a while, get one vein or so that has a little red or so. Variegated meadowhawk, I call this my 1970s meadowhawk, that avocado green and that mustard yellow from the 1970s, that's this guy. They should be called variable meadowhawks. Their colors change with age, both the males and the females. So this one is young. It has beautiful yellow dots, but it doesn't have the yellow stripes associated, or the white stripes associated with it. And it's all starting to turn red, but no other real markings, like, for example, this one here. And this is the female again. The more red with this greenish 1970s green, avocado greenish color is the males, and the yellow with these white portholes looking are the females. Common green darner, we've talked about them a little bit today already. They are the migrators, and they are, if you see a huge dragonfly that is half green and half blue, this is it, at least up here. There's a couple other species further south, but here it is only this species that has that. And the female, the abdomen can be purple or almost tan color, but that broad, huge thorax and head that's completely green, that's the common green darner. We have the 8-spotted skimmer, and I forgot to add the 12-spotted skimmer on this. But if it were the 12-spotted skimmer, the tips of the wings would also have black. The spots is the black spots on the wings. So when you have 1, 2 on each wing, you get 8. And if you add a dot at the tip of each wing, you get 12. Again, we've got the pruinosity just barely starting here. You can see over here, the white has taken over. And do you see these little shining spots there? That boy has had some action. That is exactly where the female puts her legs when she's in copula. And so he has been buffed. We have the widow skimmer and the common whitetail. They perch often on the ground or on the tops of stems. You have to look at where the black is. Both have completely white abdomens once the pruinosity takes over. And here the black is next to the body. I think of that widow wearing a black shawl when she goes to the funeral. That is the widow skimmer. And the common whitetail has a band going across all 4 wings that are black away from the body and not at the tips. We have the western pond hawk. Green is female and juveniles. Blue is actually pruinosity. So this particular type of pruinosity turns blue rather than white. And here you have a male that is kind of in between. You can kind of see a little green in there. So when he's a juvenile, he's green. And as the pruinosity develops, he turns blue. And then this is the blue dasher, which does something similar, but it has a white face instead of a green face. And behind the eye, there are these little green spots. And on these guys, they're brown. So you can tell even when they're not looking at you. The wandering and spot-winged liners are basically yellow. They hardly ever land. They look like cigars in flight to me. And these are the ones that have the longest insect migration in the world. So they also do it multi-generational between India and Africa. And the more research they do, the more places they go. They are, only place they aren't found is Antarctica. So they are all around the world, and both are found here in Humboldt. The blue-eyed darner, one of the first ones to come out in spring. This is here at the Marsh. It's along one of the paths. So they will often use the paths to patrol back and forth, or the edges of water. They're looking for the females. They have bright blue eyes. Now, a lot of the darners have blue eyes, but these are like blue on steroids, especially when it's nice and warm. And the females on the blue ones tend to be green or yellowy, but they do have a blue form. So sometimes they like to, look like the boys. Their face is also super blue, and they have this very forked appendages that are only this species has. And for the females, you can look at, this is segment 1. Remember, we talked about segment numbers, and this is segment 2 and segment 3, and the patterns are different. Jim Johnson figured this out because the females for blue-eyed darner and California darner are almost impossible to tell apart, but this is perfect. And here's the California darner. You can see it looks a lot like the blue-eyed darner. The face is lighter, and it's just not as the same kind of bright blue, but when they're flying, it can be hard to tell. And I added this one. This is a riverine species, but the county record for the species is right about 100 feet away from this building. And what happens with riverine species is any water that's linear looks like it's a possibility. And so this guy was probably flying around and saw the river-like slough over here and thought it might be a good thing. He didn't know it was saltwater. Okay, moving on to some damselflies. We'll start with the bluets. So the bluets are blue. They look like little blue needles in the grasses and on the emergent vegetation of ponds. Again, they hold their wings along their sides. We're not going to go over dancers, but dancers hold their wings above the body. So just think of the ballerina. They always hold their arms a little bit out. So the dancers hold their wings a little further up. For many of them, you really need to look at them super closely. And a hand lens, or again, using your binoculars backwards if you can get them in hand, works. And this should be 4 species. But one of them we almost count, or 2 of them we almost count as one. So so when you do look at the appendages, you're looking for the shape. Like some of these have buttons, and these hooks are different, and you get into the weeds, and sometimes they're even forked. But how important is it to know the exact species at all times? Just think about enjoying them. One of the other things to look at are these little eye spots. They all have them, but some of them are more dumbbell, some of them are rounder, some of them are teardrop shaped. For the Thule bluet, which you found mostly on ponds, they are more black than blue on the abdomen. If you look at all the segments here, they have very small eye spot, and they have this little urn shape on S2. The northern or boreal bluet, those are 2 species. We often call them nobos because you can only tell them apart under magnification. And they are more blue than black, and they don't have that nice little urn on S2. And so like I said, we often just call them nobos because you really have to have them in hand with magnification. The familiar bluet have more blue than black. Also, they have super small eye spots. And the top appendages are longer and it makes it look wedged right here. And then they have this little button that you sometimes can even see if you have good eyesight, which I used to, but no longer. You can see them with your bare eyes if you get close enough. The forktails are even smaller needles. They're like the tiny, tiny needles in the vegetation. And they tend to have green eyes at the bottom and black on top. And then their thorax and abdomen tend to be black. And then the tips are blue again. So blue, black, blue. And these are blades of grass. This is how small they are. And the males all have these nice little 4 spots. It's so nice of them to just have the same outfit. The females, though, they have a closet full. So again, male, 1, 2, 3, 4. Male, 1, 2 on this side, 3, 4s on the other side. Here you can really see how the top of the eyes are black and below are green. The females, this is not even close to how many outfits they have. Sometimes these stripes look like exclamation points. They start out orange when they're young, and then they color up even more, and they can be light blue, they can be dark blue, they can, oh my goodness. So when I get forktail females, I rule out all the other forktail females before I call it Pacific forktail. Oh, and they are, the reason I have the star here is they are the most common just about everywhere you go, and especially here at the marsh. They're at the ditch in the parking lot. They're all over the marsh. And they are the first one to come up and one of the last ones to leave. So they're here as close to year-round as you can get. The western forktail looks very similar, but it has more of a greenish hue than a bluish hue, although the lighting can really mess with you on that. And the females here become pruinose once they've mated. But you always see the lower green eyes, and the pruinosity makes them look more chunky. They're not, it's just a visual effect. When you get them young enough, you can see these little rings on their abdomens, and they're the only forktail that really have that. And then for spread wings, these are the only damselflies that don't necessarily hold their wings all the way up, but they don't hold them out either, like dragonflies. They like to be the betweeners. They're mostly black with huge blue eyes, and we do look at their appendage shapes, especially the middle ones. For species where the pruinosity, this one has pruinosity 8, 9. Some of them have some on 1, 2, or 3. So those are the kind of things we look for when looking at spread wings. The spotted spread wing has a little black spot right here on its abdomen that you can't see on this photo. And then the black spread wings, when they're young, look a lot like emerald spread wings. And so I'm finding out that probably every record of emerald spread wing are probably spread wings here in Humboldt, but I haven't been able to verify or unverify all the locations yet. And then just for fun, this Saturday, this just happened, Olympics, which is just a big North American and South American dragonfly blitz. You go out, you take pictures, and you can upload it on either Odenates Central or iNaturalist. If you go on iNaturalist, you have to join the project, okay? Olympics, September 2024. The Dragonfly Society of Americas does this every year, and they change the timing. So sometimes it's in June, July. This is one of the later ones, and that's because dragonflies use different time periods depending on species. And then we also have one in the winter for South America, because obviously their seasons are opposite of ours. But we do still have dragonflies in January, February, March here, if you go out in the woods where they're overwintering. And again, starts this Saturday for a whole week. And ta-da, more faces because I love them. So, questions? Oh. Oh, okay.
Sorry.
All right.
When you put the tracking device on them,
Yeah.
what percent of the body
Oh, I knew somebody was going to ask me that. I don't remember what it was, but we did look at using the same kind of percentage as for birds. And that was one of the problems with the Modus tags. We felt that it was a little too heavy and they could still fly with it and everything, but it just didn't feel right. The new ones are so light. It's like nothing.
Do they still work in bird food?
Not very loud, is it?
Do they still work in bird poop? We don't know, but really, when you think about it, the birds that eat the larger insects also regurgitate pellets. So most likely the radio tag would come out that way. But there haven't been studies done on that. Oh, how long they live? I'm going to try and remember to repeat the question for the people that are online. So one person asked, how long do dragonflies live? Well, in the aquatic state, in the aquatic part of their life cycle, it is weeks to years. And then in the aerial form, it is weeks to months. So very short. They come out of the water really to have sex and reproduce. And but in the aquatic phase, some will last 5-6 years before they come up. It depends on species.
I have a related question. Juveniles?
There are juveniles.
Juveniles that are adult.
Yeah, right. They've emerged, but they're not sexually mature yet typically. And the coloration and everything tends to be similar to their sexual maturity, much like humans, right? We look very juvenile before we're sexually mature, but there's a period in the middle where we could go either way.
Does anybody know if they hybridize at all?
Okay, do they hybridize? There are a few species that do hybridize. Jim Johnson's doing a lot of really good work on that. There's not that much of it, but it does happen for some species. I don't want to give everybody a chance.
You know what has happened with the populations over the last few decades?
So what has happened to the populations in the last few decades? We do know for many species, the numbers have gone way down, and that just tracks with not having what am I trying to say? With the removal of aquatic habitat. So, however, dragonflies have been around for 300,000 or 300 million years. And they kind of know what they're doing. That's not to say that there aren't some in trouble. The Heinz emerald dragonfly, which was my spark animal, is endangered. And in Illinois is pretty close to the brink. And we might have turned the corner. We're not sure yet. We're hopeful. And there are some other species that are rare and struggling. But overall, I would say they're doing decent. But if we keep going the way we're going, who knows?
Yeah, I have 2 questions. One is very general. Are damselflies usually smaller than dragonflies?
Damselflies are usually smaller.
And I also wanted to know when they do the migration, does it tend to correspond to when birds that go south because it's warmer temperatures? Maybe they follow seasons or food source, or is it some other reason?
So one study talking about timing of migration, one study looked at temperature and they could not find a relationship. They did find a relationship with winds. So maybe it's something to do with light and how much light there is in the day to start thinking about when the wind is in the right direction to take off and go. And that's very much similar to songbirds, actually. So, so that's that.
I have a question about their flying ability.
Mm-hmm.
I'm asking because the best documentary I've ever seen is on Netflix. It's called Life on Our Planet.
Yeah.
The whole evolutionary sequence. And they had a film sequence from the Danube Delta in Europe, where these dragonflies would sit on a stem and you get a slow motion picture of a frog jumping out of the water and trying to capture these dragonflies, and they mostly miss, like a huge percentage of the time. And
Yeah.
dragonflies could do barrel rolls, or they could fly into the water.
I'm telling you, they take hummingbirds and put them to shame. I mean, we look at hummingbirds and go, my God, the flights thing they do. Now put second set of wings on a hummingbird, and imagine what they can do. And the military has literally been trying to study the way that they can control their wings and do these barrel rolls and these turn on a dimes and putting the thrusters on. When I'm netting them, sometimes I can see them in my net and they go, oh, I guess I put the afterburners on, and then they leave in front as I'm swinging. They are absolutely amazing. And they do have that 360-degree view. So avoiding predators, imagine that. Not only is it good for them seeing their prey, but they can see movement all below them, above them, to the side, behind, in front. So as soon as they see the movement, they can get away. And so, yeah, and then there was that one other documentary where they looked at the success rate of catching prey. And, lions have like this god-awful percentage. I don't remember. I want to say it was like 40%, but don't quote me on that. Success rate on catching their prey. And dragonflies have something like 98%. They are just the top predators.
Do you know about the other side of that coin? Like, how successful are birds at capturing?
I do not know how successful birds are, but I have seen them do the same thing as you mentioned with frogs, where they see the bird coming and they just turn on a dime and go. But if you'll notice that swallows are one of the species that use dragonfly as food a lot, and they also have pretty good acrobatics. So and then kestrels, falcons in general, are also really good, but they're also super fast and can do, they're super fast, hit them before they can notice sort of methodology. And if you look at migration of like falcons in general, they often are eating dragonflies while migrating. And so it's possible that as you have these mass swarms flying, it's easier to pick one or two off here and there. And actually, when I'm going out chasing dragonflies, I have better success during field trips. And it's because there's other people around creating movement. So my movement doesn't shock them. I'm not the only movement. There's a bunch of movement. So sometimes it's the swarming that allows the success.
Can dragonflies breed in brackish water, or they have to have fresh water?
Can dragonflies breed in brackish water? There are a couple of species that can, and those tend to be like in the Gulf Coast area. The plateau dragonlet, I think, is one, and I can't remember the other, but there's only like two or three species that can use brackish water.
Is your Zoom presentation going to be available to others through media of some sort?
I don't know.
Yes.
Yes, there you go. There's the answer. Yes.
It'll be on our website for Friends of the Arcata Marsh.
Okay, it'll be on the Friends of Arcata Marsh website.
So they can mate together in motion?
Yeah, they can fly when they're mating. So what happens is the male attaches himself to the back of the head or the thorax, and then the female decides whether she wants to mate with him or not. She has to accept, and then she'll take her abdomen and put it up to the secondary genitalia of the male, and that creates that circle. And in that methodology, they're both facing forward, and so they can fly that way. Do they actually go through copula that way? Probably not. They do land and do their thing. And if you watch them, you'll see that the male goes shimmy, shimmy, and they basically have a Swiss Army knife, and they go in there and they scoop the sperm from previous males out before depositing theirs. Okay, so that shimmy, shimmy you see is the scooping out. And then that's one of the reasons they're guarding. Remember, we talked about hover guarding or tandem guarding. They want to make sure that it's their sperm going to the eggs and that no other male takes their sperm out. So they're going to keep watch over the females, make sure that they don't have extra copulatory.
That female choice thing is starting to sound universal, because birds.
Yeah.
Female choice is like.
Female choice is much more, as we learn more, we are seeing it more and more. It's, choice is a human thing too. That's a human concept. But you can see sometimes the female, you'll see the male grab the female and she'll shake him off. Now, is that because she's not ready and she hasn't finished producing her eggs, so she has no interest? What you'll find is the females are actually going away from water when they're younger. They go out and feed, they grow their eggs. If they were near the water when they weren't ready to mate, they would be harassed all day, every day. And how much time can you spend feeding and making eggs and all of that? So they tend to go away from water. And that's why when you go to water bodies, whether it's rivers or lakes or ponds or marshes, it's the majority of what you'll see is males. And that's why a lot of the guidebooks really only look at males or have very little about females, because you just don't see that many. You just don't. So
Well, human research, medical research has been primarily on males.
yes,
because females are complicated hormonally.
women are way complicated in more ways than one.
So can they land in the water to be able to lay their eggs in the water?
They don't land on the water. They land on vegetation, and some will land on like vegetation and then put their abdomen underwater and lay it on the vegetation. Some will put it in stems, and then some will just tap their abdomen, like meadowhawks will go down and they'll just like flick their abdomen, and they're just flicking eggs into the water.
But the eggs have to be in the water. That's something to feel.
Well, so there's the great spreadwing. There's always exceptions. I just love it. The great spreadwings actually lay their eggs in like alder and willows on dry streams in the fall.
So how does
And then in the winter time, where this is really cool, because we have that 2-season lifestyle here. It's either raining or not, right? So the creeks are dry, and then when the rains come, the trees start pumping extra water, and it forces the skin, the bark, which is thin and more skin-like, to swell, and it pops the eggs out. And now you have water, because that doesn't happen until there's enough water for the trees to drink. And so most likely those waters, even though they're riverine and they are probably connected to areas with fish, probably don't have a lot of fish right then, because it's new. So and then I've also seen bluets laying eggs in stems in roadside ditches. And if you pay attention, and I've worked in some of the areas over and over again, so I know which parts of the ditches stay wet longer. They're laying their eggs where it stays wet longer. How do they know that when it's completely dry? I have no clue, but they know. They know.
How big is a brain?
in their eyes?
Tiny, way smaller than their eyes by a lot,
They see the colors that we see on them.
Do they see the colors that we see? Very good question. Yes, and also into the UV. So there's this gal, I can't remember her name, I wish I could. She did a study looking at vision of dragonflies. Super smart woman. Don't explain to me how she did it, because that was like, whoop, way over my head. But when UV light hits water, it splits a certain way into the different colors, right? We see that with prisms, but it's even more as you get into the UV area. And so dragonflies can go fly way up in the air, and they know where all the water is, because they can see that UV light and how it splits. So the other reason that, so that can also mix them up. Fresh blacktop, same thing. It cuts the UV rays the same way. And same thing with brand new shiny cars. You'll find dragonflies trying to lay eggs on cars. When you go to the desert, and I'm one of those people that drives until I can't drive anymore, and then I'll take a nap at the side of the road and keep going. So when you drive through the desert and you park off to the side and take a nap and you wake up, you might find wandering gliders, like 100 of them, just circling your car, because it thinks the car is water, because it's splitting the UV rays. They're like, ooh, new body of water, let's go check it out.
So are you
So-
the person that would bring a cup of water for them?
No.
Around here, there seem to be a lot more dragonflies on Klamath River than the other rivers. Is that?
Oh, so the question was, there seems to be more dragonflies on the Klamath River than the other rivers, and I would say no. I think that access is partly there. And then also maybe closer to the ocean, a lot more rocky and less emergent vegetation and lots faster flowing water. So once you start getting up the river a little ways, Trinity River completely full. Eel River, when you start getting into the eel, where it gets slower and really goes. I was out with Kim Cabrera last month, and we had tons of dragonflies up and down. She was showing me where they were coming up out of the rocks and showing me she's a tracker, and she learned how to look for sand dragons, and their nymph create these little paths in the sand. And then if you follow those paths and look at the end of the path and you take your hand and you just scoop it, there it is. And I asked her, I go, how'd you figure that out? She goes, oh, I was just curious. So I put my hand in there, and I'm like, that's pretty brave. You didn't know what was at the end of those little trails. So, yep.
I read somewhere recently, and I'm sorry, I can't remember what the species was, but there's some kind of a cannibalistic dragonfly that actually predates other dragonflies.
Okay, so she read something about dragonflies predating other dragonflies, and the answer is yes. And basically, almost all dragonflies will eat whatever they can catch, and it doesn't matter that it's another dragonfly. There is somebody who's looking for research on within species, and that for some reason doesn't seem to happen as much, but I wouldn't say that it never happens. But like, for example, the Western pond hawk that we talked about, they specialize on eating other dragonflies. Yep, the dragon hunter. It's named a dragon hunter. That's not on the West Coast. That's east of the Rockies. The dragon hunter specializes on eating other dragonflies, and big ones, you know, not just the little ones. They can often catch insects bigger than themselves. As adults.
This is not the nymphs.
Well, yeah, the nymphs, they're pretty. If you put a bunch of nymph of different sizes into a cup of water and leave them overnight, you will not have as many the next day. So yes, they are eating each other even in the aquatic phase. And in certain times, that's required. So like we talked about the wandering glider following these storms and taking these bodies of water that are just ephemeral. They just showed up with this big storm. What do you think they're eating? There's no insects in there either. So they lay a bazillion eggs and they eat each other, and the toughest ones win.
Wow.
So in that case, it would be considered cannibalism.
Speaking of eating, how long their mandibles are just chitin, right? How fast do they wear out?
They don't.
Oh, they don't?
Well, they don't. So,
Do they grow new ones?
well, so in the aquatic phase, they're going through their molt, right? So they get fresh ones, you know, just like crabs. As they grow, they have to get rid of their exoskeleton. And they go through 13 or 14 molts. And then as adults, they're only living weeks to months. So how long does it really need to last? And chitin's pretty darn strong. It's actually pretty durable.
So there's no, I think you said that one of the scientific names was the toothed one.
The toothed ones, yes. So the order is called Odenata. So
There's something about them.
So- yeah, so you can kind of see it on this guy. And especially in the nymph stage, they have like these scoops, and they hold it like this. Some of them are mask-like, some of them are more plate-like, like this. But they often have these like serrated, like almost finger-like projections, and they kind of look maybe like teeth, right? And they jet out their mandible and catch whatever it is they're trying to catch, and then bring it back to their mouth.
Like alien.
Like it, look, you guys, Alien, all of the monsters on Alien are all insects. Once you start learning about insects, they are all insects. But as far as the dragonflies, they have these like tooth serration type things on their mandibles. And that's where that comes from.
Wow.
Any more questions?
Well, it's after 8. Your talk was delightful.
Well, All right, I guess that's it. Bye-bye, everyone.
Final round about the news.